write the square minus 20. Okay, this is my first expression. I'm going to write the next one side by side. X square minus 10x plus 25 into square minus 2x minus 24. And I am asked to calculate the LCM of these two expressions. So to get to LCM, first I need to factorize it, make it, though it's already basically into factor of two expressions or two polynomials, but I want to see if it can be further factorized because I cannot see anything which is common between these two. So what I am going to do is I'm going to look at this again, and when I'm looking at this part again, what I'm seeing here is it's looking somewhat familiar, wherein if it is x square and say this is 8x, right? If I'm writing it 2 into 4 into x, why did I write it as 2 into 4 x? Because I saw this as x and this was more like looking like a 2ab to me, and this was looking like a b square. So it was a square minus 2ab plus b square. I could see that, so that's why I'm going to write it like this. Now, again looking at this, this is looking like a square minus b square because 25 is 5 square. So let's do 2 steps again. X square minus 5 square. Now, this expression is x minus 4 whole square, and this expression x square minus 5 square, so I'll write x minus 5 into x plus 5. Okay, so now I've got expression which is more in terms of what you call single degree equation, single degree polynomial, and here too I will want to write it in that fashion. Again, I can see this is more like a square minus 2ab plus b square when my b square is 5. So I can write it as like x square minus 2 into 5 into x plus 5 square. And here it's x square minus 2x minus 24. It is not looking like x square minus 2x minus 1 or anything. But if I'm able to factorize it, like this is 24 and 4, then only it will work. 6x minus 4 plus 4x minus 24. This will become x minus 5 whole square. This will become, I'll take x common, then it will become x minus 6. When I take 4 common, then it will become again x minus 6. Now this will become x minus 5 whole square. This will become x plus 4, and this will become x minus 6. So now I can take the LCM here. What I can see here is the distinct terms are, one is x minus 4, so let me write x minus 4. Then I see x minus 5 and x plus 5. So first I'm going to write them. So this is x minus 5 is taken already. X plus 4 is not there, so I'll write x plus 4. And then x minus 6 is also not there, so I'll write x minus 6. Then I look at all this expression and take the highest power of this. So x minus 4, highest power x minus 4 is 2, so I'll take 2. X minus 5 highest power is 2, so I'll take 2 over here. X plus 5 highest power is 1, so it's 1. X plus 4 highest power is 1, so it's 1. And x minus 6 highest power is again 1, so this is 1. So this is what is my LCM is going to be. Okay, this is what is my LCM here. X minus 4 whole square, x minus 5 whole square into x plus 5, x plus 4 into x minus 6. And if I have to take an HCF of this again over here, so then I have to look at the common terms here. So x minus 4 is not here, so I cannot take. X minus 5 is there, so I'll take x minus 5. X plus 5 is not here, so I'll not take x plus 5, and x minus 6 is as well not there. So this is what is going to be my HCF, this is what is going to be my LCF. One thing which you will see, that if I am multiplying say HCF, this is what I wanted to do here. HCF into LCM, what do I get? So what I get here is that I'll get x minus 4 whole square, then I'll get x minus 5 whole cube, because this is 1 power, this is 2, so this will become 3. Then I'll get x plus 5, then I'll get x plus 4, then I'll get x minus 6. If I'm calling this as px and calling this as qx, for example, now I'll do px into qx as well. what do I get here is that x minus 4 whole square into x minus 5, because there is one power over here to here, then I have got x plus 5, then I've got x plus 4, and then got x minus 6. So what you can observe here is that HCF of two polynomials, SCF and LCM, multiplication of that would be equal to the product of those two polynomials. This is what was the case even in terms of numbers also. When you multiply the HCF and LCM of two numbers, it will be equal to the product of two numbers. But here the expression, you will see that there will be at times plus and minus sign as well will be coming, because here what I'm going to take, the expression could be taking a positive turn and as well as negative term. So this is an expression wherein SCF and LCM of two expressions, basically polynomials, multiplication of that would be equal to the product of two polynomials, and the sign could be either plus or minus. This is what we will be seeing later. While in terms of number, when you look at two numbers, you can multiply SCF and LCM, and that will be the product of two numbers as well. I mean, you can try it. For example, you have number 2 and 6. When you have SCF of these two numbers, you can write 2 as 2 itself and 3 as 2 into 3. So HCF of these two numbers is 2. LCM of these two numbers would be, I'll have to write 2 and 3, and then I'll have to write the highest power of these two, and which will be actually equal to 6 here. So HCF is 2, LCM is 6. LCM of two numbers would be multiplication of these two numbers. So I'll have to see this expression if it is called factor. Uh, so here, this is what I wanted to show you. So LCM we calculated. The next one, HCF as well I could calculate, and there I'll have to see what is the common expression. So okay, here the LCM was being asked, so I did calculate the LCM. So here, as you could see that I have got x minus 4 whole square, x plus 5 whole square, x minus 5 whole square, x plus 5, x plus 4 and all. But here, the expression is not in terms of that. That is either x minus 6. Okay, the x minus 6 is there. I don't have x plus 6, so this is gone. This will be there. What about these two? Now what they have done is basically they've sort of multiplied two things to get to this. We can do that as well. So 3 and option 1 and 3, as I can see that again there are more like two expressions, x to the power 4 minus 41 x plus 400, and another one is more like x square minus 9x plus 20. So as you could guess that the what will be the power of x to the power 4 max, rather than what would be the x to the power x is highest power. So when it is 4, if it is getting multiplied by 2, it will be basically 4 plus 2, 1, 6, and then finally if I'm multiplying it by 1, then it will be 7. So the highest power would be 7, and here highest power would be 2, then 2, 4, 5, 6, 7. So again, out of these two expressions, I will choose third one, because this one has got only x to the power 4 and x to the power 1. If I multiply it, I will get x to the power 5, which is not going to be my answer. So instead of calculating the entire thing, I would just choose this.
Alright, so let's try to further simplify this to finally get to the answer which is given in the book. So what we can do here is that we can write this as x minus 4 into x minus 4 into x minus 5 into x minus 5, and then x plus 5 into x plus 4 and x minus 6. So this x minus 6 will be staying separately, but let's try to combine x minus 4 and x minus 5, and then same x minus 4, x minus 5 and x plus 5 and x plus 4. So when I combine this x minus 4 into x minus 5, and then here too I will combine x minus 4 into x minus 5. Why am I doing it? Because there is an expression which is involving 9x, and this is what I am seeing over here, and this x plus 5 into x plus 4 into x minus 6. So what do I get here? I will get If I multiply, I'll get x square minus 4x minus 5x and plus 20. Similarly, here I'll get x square minus 4x minus 5x plus 20. Here I'll get x square plus 4x plus 5x plus 20, and here I'll get x minus 6. Now what do I do again? So this will become x square minus 9x plus 20. So this is one expression which is there, so I'll not touch this. Then this is also gonna become x square minus 9x plus 20, and this will become x square plus 9x plus 20, and this is x minus 6. Now what do I do after this is, I'll keep this as is, x square minus 9x plus 20, but I'll try to rearrange it again. How? So I'll rearrange like x square plus 20 minus 9x, and I'll write this as x square plus 20 minus 9x plus 9x. So now this will again become a plus b into a minus b. So I can still write it as x square minus 9x plus 20, and this will become a minus b into a plus b. So this will become a square plus b square. So x square plus 20 whole square minus 9x whole squared, and that will be that. And then this will be x square minus 9x plus 20, and then this will become x square plus 400 plus 40x square. So this is not x square, this will become x to the power 4 because this is x square here. So this will become x to the power 4. So a square plus b square plus 2ab. So, and here I will get minus 81x square into x minus 6, and finally this will give you x square minus 9x plus 20 into x square minus 41, not x square again, x to the power 4 minus 41x square, and then plus 400 into x minus 6 or x plus 6, whatever it is. So this is what will be your option C.
LCM of this is given as x square plus 7x plus 10. So this is the LCM. So they are asking what will be the HCF. Okay. So as we just learned that LCM into HCF is simply the multiplication of these two terms. LCM and HCF, multiplication of that is product of these two expressions px and qx, okay, will be equal to px into qx. Now as you could see, HCF was this, okay. So HCF is equal to qx itself. So now if I'm writing px, but if I'm writing LCM into qx, because HCF was qx itself and px into qx itself, so qx is gone. So LCM is this polynomial itself. So x square plus 8x plus 16 into x square minus 9 would be the LCM. And then they have, what they have done is they have sort of simplified it, and they are asking which is the answer. So when you look at this is nothing but x plus 4 whole square. This is x square minus 9 itself. So x plus 4 square into x square minus 9. So this 2 would be the answer here. You understood just now we were discussing this concept that LCM and HCF of two numbers, the factor tree which we are saying, would be equal to the multiplication of these two expressions. Since they have given us the expression HCF itself, then we have found out the LCM of this number will be this function itself, px, okay, the polynomial itself. So here they are saying that the zeros of this polynomial is minus 1 by 2 and 3 by 3. Okay. So what would be the value of a and b? So what can we do? If we put x is equals to minus 1 by 2, what will happen here? 3 into minus 1 by 2 plus 2a into 2 into minus 1 by 2 plus 1, right? And basically this will be 2a minus 3 by 2 into, this will become minus 1 plus 1, which is going to be equal to 0 into 2a minus 3 by 3, which is going to be 0. And then this is coming all right. Then the second thing is b by 3. If I am just going to do, then what will happen? 3 into b by 3 plus 2a would be equal to 2 into b by 3 plus 1. So in this is a 0 of this polynomial, then this should be equal to 0, which means that either b plus 2a is equal to 0 or 2b by 3 plus 1 equals to 0. Okay, this is what it means, right? So if this being the case, 2b by 3 will be equal to minus 1, so b will be equal to minus 3 by 3, or b is going to be just equal to minus 2. So then the value of a is, one of the values of a is basically going to be minus b by 2, as you can see here.